Well, let's start with the basic example. And um, I will say that this is available in the form of a step-by-step tutorial on a website called Real Python, how to build this game. But I want to show it to you, and it's this little missile one that I already showed you a picture of. Okay, so this one, you just fly the airplane, and it just uses the arrow keys on the keyboard. You can't shoot or anything. And so far, it doesn't even keep score. Now, on the original tutorial, it has little clouds that move in the background, and obviously, at some point, their missile will hit the airplane, and then the game just stops. It's kind of boring, but it illustrates a lot of the things that are part of the game. So it's a good place for us to start. So let's walk through the code, and I can show you some of the things that we're doing. First thing we're doing is we're importing Pygame and random, the whole thing. And then you can see we're going back and layering in. We're importing from pygame.locals. Those are just a set of constants that that do a few things for us. RLE acceleration is a graphics acceleration that works with your graphics chip to make the animation more smooth. These, as you may have guessed, are keyboard up, down, left, right, and the escape key. And a key down event is a constant, and quit. Okay, so those are just types of events and ways to address hardware interactions that make it a lot easier for us to detect. The next thing, we've got two constants that we define. You can tell they're constants because they are all uppercase, screen width and screen height. Those are nice because I could just enter those numbers throughout the program, but having them set as constants at the beginning of the program allows me to easily change the size of the program window if I want to. So that's a nice thing to do. And then we get straight into it. We have a player class, okay? And there's nothing new about this, okay? We have covered all of this material. You may not remember all of it, but it'll come back to you in a second. We're creating a class called player, and it's based on pygame.sprite.sprite. So we are extending the Pygame sprite class. So all of the properties and methods and things that a sprite has, we are now extending in our class called player. Now you remember the initialization. So when the player is spawned, it will run this, and you can see it's calling the super initialization. And then we've got, and notice also that there are no initialization arguments. So we're just creating a player, and we're saying the surface, remember the surface is the visible part of the sprite, equals pygame.image.load, and I'm giving it an image. It's just the airplane. The airplane image I have saved right here in Pygame images, and I call it jet. That's it. Super realistic, I know. Now, note that the image comes up with a white background. It actually is a PNG file with a transparent background. If I want to, I can make the background transparent, or I can set it to white and then tell all the white pixels to be transparent, which is what I'm doing in this game here. So it's loading that image, and then I'm telling it right here to use that color, which is white, 255, 255, 255 is white, and set that to transparent. So when I created that jet image, I create it with a white background, I tell it the white to be transparent. If I want to, I can just create the image itself with the transparency. It works both ways, and then you won't need this line. So that surface is defined. I've set the transparency, and then self.rect for rectangle is based on the surface. So all I'm saying is set the rectangle to be exactly the same size as the image. I could make it bigger or smaller if I want to. I can set the rectangle manually, but it's the easiest way is just to grab it using the image and make sure that if you have like an image this size, that your airplane's not that big, right? Because then your rectangle will be much larger than the visible part of that image. You want your whatever your image is to fill up the entire square or rectangle. Okay, so that is it for the visual and the physical presence of the sprite. Now I'm creating an update method, and tip right here, pro tip, all your sprites should have an update method because Pygame gives you a way to call the update method for all your sprites at once. So when you go through that game loop, you can basically say, hey, on all sprites, let's update everybody. So, and then it does what it's supposed to. And you can kind of read this code pretty easily, right? You can say if press keys equals keyboard up, keyboard down, and you can see the coordinates. If we're moving it up, it's -5 on the y. If we're moving it down, it's 5 on the y. -5 on the x is to the left, and to the right is 5. Now, if I want the plane to move faster, I make those numbers bigger. If I want the plane to move slower, I make them smaller. It's pretty simple. Okay? This code will keep the player on the screen, and all it basically says is if the left-hand side of the rectangle is off the screen, don't let it go any further. Same with the right-hand side. If the right-hand side of the rectangle is off the right-hand side of the screen, which is the same as the screen width, and that's why we're using those constants again. And the top is 0. And again, if the bottom is below the screen height, then stop it from going off the screen. So we don't want it to go off the screen. In the previous game where I showed you, the asteroid one, what happens when you go off the right-hand side of the screen is you appear on the left-hand side of the screen, and so on. So this is where you get to decide what are the rules of my video game world, which is kind of a powerful feeling, right? You get to define exactly what happens in that world. Now I'm creating the enemy. In this case, the enemy is the tiny little missile. Nope, not that one. There it is. Okay, so I got the missile again. I use exactly 5 colors in this. So there's gray, black, red, yellow, and white. And so I'm just going to make the white transparent there. This is super low resolution image. These are the actual pixels. So this is an image that's probably like, I don't know, 15 pixels wide. No, 20 by 10 is the dimensions of that image. So these are really small. When your screen is 600 by 800 pixels, you got to draw stuff on there really small, or else it's going to not fit. Okay, so again, we're loading the image. We're setting the color key, which sets the transparency. We're using the rectangle here. Now notice, this is a little bit different. But what I'm doing is I'm saying the rectangle is going to be created by self-surface get rectangle. But then I'm passing in an argument, and I'm saying set the center of that rectangle to a random location on the screen. So when those missiles appear, they're actually not set to be on the screen. It is a random location that's off the screen over here somewhere. So those missiles get created here, and all of them fly onto the screen this way. That way it looks like they're being shot from some mysterious unknown source. So they're all flying onto the screen at random speeds, using random like timing and a random start location. So again, so it sets the center somewhere off the screen, but somewhere between 0 and the screen height. And then the speed of the missile is going to be set to a random integer between 5 and 20. And again, the speed is just a property of that object. Okay, so here's the update. Remember, every sprite should have an update. Every time this gets updated, I don't have to worry about what keys are pressed or anything like that. All it does is move to the left at its speed. So literally, self.rectangle move negative self.speed, which says we're going to move to the left somewhere between 5 and 20 spaces and not vertically at all. If the rectangle on the right, if the right side of the rectangle passes the left side of the screen, then we kill the sprite because we don't need it anymore. Okay, that's important because what happens in Pygame is if those missiles don't disappear after they cross the left-hand side of the screen, you will have an infinite number of missiles being tracked by Pygame flying into infinite space on the left-hand side of the screen. And that doesn't seem like a problem, except that constitutes what's called a memory leak in your program, which will eventually take down your whole computer. So you have to think about these objects. They exist when they're not on the screen, right? We blit them onto a screen that we're not looking at, but even when they fly off the edge of the screen, if we're not managing those objects, they still exist. And so if we're spawning 20 objects a second and we're not killing them at some point, we're in trouble from a memory standpoint. Okay, so there's only two objects in this game, the missiles and the airplane. So we've created those. This is where we start the game. So pygame.init initializes the game. You can see we've set the screen size right here. So pygame.display.setMode, it takes a tuple with the screen dimensions in it. Now we're creating a custom event. This is event-driven programming, but with a loop. It sounds familiar because that's what TK interface did, right? We're waiting for events to happen on screen. So what we're doing is we're creating a custom type of event called add enemy, and we are incrementing a constant called pygame.user event. So we are saying whatever the newest event is, we're going to make an add enemy event. And every 250 milliseconds, so 4 times a second, we are going to add an enemy. That's all it says we're going to do. So what we're doing is we're saying, how often do we add an enemy? Well, 4 times a second. So we're creating an instance of the player object, and then we're creating groups. There's 2 groups. There's an enemies group, and there's a group called all sprites that includes the enemies and the player. And the reason that we have an all sprites group is because that allows us to update everything at once. The enemies we have for a different reason, and I'll show you that in a minute. So running is true. That's just a while true loop. You can see that right here. So, but we're using while running instead because then we can set running to false and it'll stop the loop. There's the game clock that measures the speed of the game. And here is the game loop itself. So the game loop is exactly what I told you. Just to refresh your memory, right? The game loop right here. User input, update sprites, draw background, blitz sprites, collision check, flip display, clock control, game over. Here it is. So the first thing we're checking for events, which is the controls. So if we have a key down, or if we press the escape key, or if we close the window and quit the game, those are events that happen. Those are the controls. If we have an add enemy event, remember those add enemy events are triggered 4 times a second. Then it adds a new enemy. So it creates an instance of the enemy, adds them to the enemies group, and adds them to the all sprites group. That happens 4 times a second. And then if keys are pressed, they are put into the pressed keys group, or the pressed keys array. And then we send those to the player when we call the update. So we're updating the player sprite. Remember, everybody has an update method. We call the update method. We send it the keys that are pressed. That way the player knows, or the player object knows, what keys are being pressed. And then we can call the enemies.update as a group. The nice thing about these Pygame sprite groups is that if they all have that update command, you can call the update method for the entire group. There could be 1,000 sprites, and instead of calling them one by one, you can just say, hey, everybody, just update. And it just does it for you. Okay, this fills the background with that blue color. And then you can see here for each entity in all sprites, for each, then again, we're using the group, the all sprites group, screen.blit. So we are drawing those locations on the screen on the card that we're not viewing. Next, we check for updates. And if we look here, you can kind of see what's going on. But basically, we're saying if Pygame sprite collide any, if a player is touching any enemy in that group, then it becomes a true statement. And all it does is kill the player and set running to false. Now, if I was more invested in this game, if I wanted to make it cooler, I'd probably have some kind of explosion. If I had multiple lives for that player, this is where I would take one of those away and then restart it or start at some point back playing again. Okay, so those are the game ending conditions. There's only one. And the last thing here is I flip the display. So I take the screen that's been drawn in memory and I show it. And then I use clock tick to make sure that this is not happening more than 30 times per second. So that I'm actually setting the frames per second at 30 for that game. If I set them to 60, you can see here the game becomes a little bit more difficult. Will it run at 120? It probably will, yeah, but not for very long. Okay, so that's an easy difficulty setting.